And so if Dr. Nakmaura, if you join me down at this end, we will like to dive deeper. If you can come down here, we'll get closer together. He's been waiting patiently this whole time, but we wanted to make sure that he had a time to discuss this this very important work that he's done. And it's a great honor to be with you today, because anybody that knows the field of clean tech would appreciate, as I said, that the light-emitting diode is a paradigm for what needs to be done to commercialize these technologies, which require tremendous capital-intensive investment. So Dr. Nakmaura, I think your distinguished record speaks for itself. So what I'd like to do is jump right into the first question and hear from you a little bit. I can't do justice to what the impact of the blue light-emitting diode is for the industry. So could you please tell us from your perspective what is really been going on, and what is the impact of this, of your great invention?
Yes, nowadays biggest issue is global warming. And in order to overcome global warming, we have to concentrate in how to save, reduce energy consumption. And so currently, LED bulb lamp is 10 times efficient compared to conventional incandescent bulb lamp. Also, 2 times efficient compared to conventional fluorescent lamp. And also the lifetime, the LED lasts at least for 50 years. So if you install LED lamp at home, you don't need any maintenance in your life. So also so LEDs are penetrating all kinds of equipment. And also, at the current adoption rate of LED, by 2020, we can reduce the energy consumption equivalent about 60 nuclear power plants worldwide. It's a huge energy reduction. Also, many countries, many people, millions of people are living without any electricity. In those regions, people cannot have a light. But nowadays, they can use LED lamp operated by small battery because LED is so efficient. Also, those small batteries are charged by solar cell daytime. So they can use clean energy to operate LEDs. So that's the reason why LED is so popular now.
It's had an absolutely enormous impact. And one of the things looking into the history of LEDs that was impressed upon me is that the green, yellow, and orange LEDs were actually available in the 1970s. And it was actually not until the 1990s, thanks to the work of Dr. Nakmaura, that the blue LED actually was realized. And so I wanted to understand, not from necessarily only about the technology, but organizationally within your work at Nishiya, what it is that allowed you to go forward and have this great invention that hadn't been done for decades until you were able to do this.
Yes. So basically, I joined a small company in Japan. It's a small company. And so coincidence, I joined the R&D department, and R&D department, my boss asked me to work for the conventional LED material, conventional infrared LED materials. So for first 10 years, I could develop those materials, but the sales are very poor. And so my dream was I wanted to develop blue LEDs. So I asked this is a small company, so I directly could go to company chairman and the president office, and I asked him, can I try blue LED? Can I do research a blue LED? He said okay, and also I asked him, please give me $5 million for my research funding for blue LED. He said okay, no problem. So also I never been to the foreign country, so I asked I want to go to the United States for 1 year. As he said, okay. So, and I could start blue LED research. And at that time, so I went to University of Florida 1 year. And at that time, there are 2 kinds of material available, zinc selenide or gallium nitride. So 1 year later, I came back to Japan and I started blue LEDs. At that time, my dream was to get PhD degree because I had only master's degree. In the United States, scientists, researcher means they have to have a PhD degree. So I wanted to get a PhD degree by publishing scientific papers. And so there are 2 kinds of material, I told you, zinc selenide and gallium nitride. All of scientists basically selected zinc selenide because crystal quality is so good. gallium nitride crystal quality was very, very poor. So nobody expected using gallium nitride we could invent blue LEDs. But in my case, I thought I never invent blue LED. Just my dream was getting PhD degree, by publishing papers. So that's the reason I selected gallium nitride in order to publish papers to get a PhD degree. And coincidentally, I could invent blue LED in '93. And so good thing is my company chairman was one of the best venture capitalists. He gave me $5 million, and he never interfered in my research. That he gave me a lot of freedom research. So without his support, I couldn't invent blue LEDs.
That's very important. So sometimes publishing papers does make a difference. So that's a good example. So we're going to come now to, in 2015, you won the Global Energy Prize, again, another huge accomplishment, and you're very distinguished for that. And the recognition was for the white LED, and that leverages off, of course, your prior work. And so the question is, you're continually looking, and we're going to go into later about this further, about linking science to innovation. And we try to always tell people that R&D and innovation are different, right? It's about trying to find that commercial connection. And so here you go from publishing papers to seeing the need for innovation in its true sense. How did you make that connection?
Yeah, because after graduation of the University of Tokushima, after getting master's degree, I joined this small company, employed with 200 employees, and revenue was about $10 million. It's a small, tiny company in Japan. And, so after joining a company, my boss always asked me to make a product. When could you make a product? You have to make a product, and you have to make a profit. Because a small company means without profit, company, go bankrupt. So initially at the university, my interest was science. Also after joining the company was my interest was science and physics. Always after research, I have to reading papers. I wanted to clarify the mechanism of science. But if I work for those things, no time make a product. So maybe 6 months later, I realized at a small company, science is no meaning. I have to make a product. So since that time, always I like labor work. I move around the company. I have to make a product. Product means move around, labor work. So always labor work. And for 10 years, I told you, I worked for the conventional infrared LEDs, and I could make 3 products. But the sales are very poor. So all company bosses became angry. And 10 years later, despite, despite I tried a blue LED. And so also blue LED research, also, in order to develop, I spent only 4 years to develop blue LEDs. At that time, same. I ignored the science. I had to make a product of blue LED. So I ignored all kind of science. Science, small science required. Just science is bright. This is if I change content. Oh, this is brighter. So that's that. Using those, basically I ignore science. So for small company, you can understand making a product is most important. That is my relation between science and making a product. Yeah.
And so coming to small companies now, I think it's very interesting. You went on now you were a professor at University of California, Santa Barbara, and obviously doing extremely well in your academic career. And decades pass, and you get these renown for the blue LED, and then you decide that there is a better way to do LEDs again, and you go into the founding of your company, Sora, which is looking at a different way to actually attack the LED market, and much riskier than one would imagine one would want to take that risk when you're very successful as an academic. So can you just tell us about what Sora is doing and how it's different from the rest of the market, and why you see the potential and why you did this? It sounds like it's very interesting if it works for you.
Yeah, so basically in 2000, I moved to the United States to become a professor from Japan. And at the University of California, Santa Barbara, this is university, so we had to try a new research. So my colleague, Professor Steve Denvers, Jim Speck, and I tried to develop a new technology of LED. It's called the gun-on-gun. Using gun-on-gun technology, we try to develop new LEDs. And we spent 7 years to develop this technology. And finally, in 2007, we could achieve big breakthrough of gun-on-gun LED technology. And we published a great paper. And the amazing thing is that, one of the best venture capitalists in Silicon Valley, name is Vinod Khosla, he contacted us. Why don't you start a company using this technology, And, okay, we can start a company. And he said, oh, how much funding you require? Any funding is okay, And anyway, we started a company. And, and also, so this is Gaon total new technology. Also, next is color. So at that time, currently all white LED made by using blue LEDs, but we have to use a different technology. So we selected violet LEDs to make white LEDs, And now we can make very good white LEDs using violet LEDs, because blue LED, always causes some kind of problem. Blue LED, very bright blue LED causes disruption of circadian cycle. Now it's a big problem in Japan, So anyway, using violet LEDs, we can make very good white LEDs, and because white quality is estimated by using CRI, color rendering index. 100%, 100 is a perfect white. And usually, when we make white LEDs using blue LEDs, this value is 85. But using violet LEDs, CRI become 95. So almost close to 100. So it means the color quality of white is best using violet LEDs. So now, so through this, our company of solar, I think, start company has to try a totally new technology, which people never tried. That's the most important, totally new thing. That's the most important.
So I think it's very interesting. And so the LED, as we were saying, it's obviously one of the most progressed clean energy technologies. Do you feel that the LED technology is getting to the point where enough has been done on innovation, or is there more that you feel can be done? Is it going to be what SOAR is doing? If that works, that would be it, or do you see that area of LEDs really having a longer lifetime in innovation?
Yes, because when I invented the white LEDs in '96, especially lighting designer used our white LEDs since '96, but all lighting designer complained about white LEDs, quality of white LEDs. Because color is, I told you, not good. There's a missing color. Best white color is sunlight. Sunlight is ultimate white color. We have to make a copy of the sunlight. Sunlight has all kind of visible spectrum is covered. But using blue LEDs, when we make white LEDs using blue LEDs, missing violet and blue, green, and red are missing. So color quality is bad. But using violet LED, it's a whole spectrum. We can cover whole visible color. So it's a perfect. So basically, since lighting design complain a lot about white LED, color quality is bad. Also, each white color is totally different. But so always I was thinking about how to solve this problem. And that's the reason. So we started solar, and we solved all kinds of problems of which lighting designer have complained. Mm-hmm. And now lighting designer love to use our solar's LED lamp.
In your time, you were starting to allude to, now you're working with a different set of actors versus the time which you were developing your technology. Throughout your career, as you've taken the science into commercialization, is there any particular stage that you found to be most difficult? Either, sometimes it would be the science, or sometimes the venture capital, getting the funding, or now building a company and taking it forward. Do you see any particular stage as having been the most challenging for you in your area?
I think the most challenging or most important thing is innovation. Innovation. So always innovation should be done at university, because the university always have to do innovation. So if we work for the innovation at university, even if it fails, nothing happens. This is university. So I think so our style is at university we kind of try to develop totally new technology, try a new innovation, and maybe in 5 years, 6 years. Right now, I never failed to develop the new technology. Never failed. Always in 5 years, I could develop a totally new technology. And then, in the United States, he published paper, many venture capitalists come to our university. Why don't you start the company? We don't worry about anything. So after venture capital, giving us funding, venture capital hire the CEO, CTO, all kinds of CFO. So I don't think most important, most difficult part is innovation. I think
innovation. That's a fantastic message,
Yeah.
and we'll close now. And I think that was a fantastic message to end on, because the notion of innovation, we want that to be one that's out there prominently, because in the academic world, few people have made it to the level of Dr. Nakmaura, and it truly is inspiring, and we're very happy to have him here with us today, giving his message and his story. And so, once again, I thank you so much for joining us today, and thank everyone in the audience for attending. And so let's give a round of applause for Dr. Nakmaura. Thank you. Thank you. So that concludes the panel. Thank you very much.
Thank you.